All right, let's get started. Thank you for joining Interface today. We have with us Elliot and Ken, who are going to be talking about ruggedized test and measurement solutions. This is an interesting topic for us. We have a whole different array of products that we'll be talking about that are built to withstand high temperatures as well as submersibles and all kinds of different conditions. So with that, here's just a quick look at what we'll be covering today in today's event. First of all, we'll define what it is that we mean by ruggedized. We're going to go through the different stresses, environmental stresses, and harsh condition categories that we'll be referencing throughout the presentation, as well as a quick recap of standards and ratings. We'll talk about different materials as well as structural options. And then we'll get into the different devices, everything from the test and measurement load cell devices, but as well as different instrumentation options. We'll also cover an important topic related to ruggedized solutions, and that's sealed products and enclosures. We'll go through a couple of engineering tips on extreme temperatures and cycling, as well as exposures to moisture and submersibles, and then finish up with a different series of applications across industries. And then, of course, our favorite do's and don'ts and FAQs. If you have questions during the presentation, please feel free to use the chat feature. We'll try to address those during the FAQ section. Again, welcome to the presentation, and I'll hand it over now to Elliot and Ken.
Thanks, Jamie. So we'll get started off here by working to define what we consider a ruggedized application and a ruggedized sensor to be. So typically speaking, we're going to be considering this as a force measurement solutions that are designed and specifically manufactured for use in extreme environments or applications. Extreme environments could be anything from extreme thermal environments to extreme shock to extreme pressure, or the lack of pressure in something like a vacuum requirement. So essentially, it's designing and manufacturing a sensor with the ability to operate within its defined accuracy parameters while withstanding this type of environmental usage. So what kind of testing types do we see that require ruggedized solutions? Really, we see it across the gamut of our typical application range, from material testing to thermal extremes, be it a high temperature or a low temperature. This high or low temperature could be present in any number of testing. Could be structural, could be fatigue, could be high cycle count. Any kind of a product that's being tested for usage in an extreme environment such as this is typically going to be tested using a sensor in that type of environment. In addition to that, it could be anything that's exposed to moisture, severe humidity, submersion, could be underwater or in a fluid of some type, or in a pressure vessel or a vacuum chamber of some type. Industries that we see this type of testing done in, again, kind of runs the gamut here. Anything from aerospace to defense. You might imagine that aerospace, we do have some thermal testing that happens in addition to vacuum testing. Vehicle testing, same story there. You want to make sure that the vehicles are tested across to how they're going to be used through any of those environments. So we'll see thermal and environmental challenges in those applications. Marine and offshore, where exposure to seawater or submersion in seawater or other material could be seen. Medical device. The example there would be saline bath type applications where submersion is required. Industrial automation, typically speaking, there could be intrinsically safe requirements around that, or just sheer product ruggedization for exposure to different hydraulic fluids, or perhaps the workers aren't as careful around these types of sensors as they would be in other lab type environments. Infrastructure, maybe a sensor has to be designed to survive outdoors for an extended period of time, monitoring perhaps loads on a structure. Hazardous areas, perhaps there's an explosive environment or other requirement that is driving a specific certification type. And then corrosive environments, be it a chlorine gas, sulfuric acid, those types of material exposures that we have to specifically choose load cell material and optimize construction around. User profiles, again, really runs the gamut of our customers. So common users, material engineers, product designers and engineers, Metrologists, even a lot of times they may have to calibrate in a given environment, and their standards or other devices have to be able to tolerate that environment. R&D test labs, very common, again, trying to simulate the type of environment that their product is going into, so need to test to those same environments. OEM manufacturers embedding a sensor into an end product that is exposed to difficult or challenging environments. Production engineers and maritime industry personnel, again, offshore environments can be very, very extreme, saltwater exposure, submersion, etc. So environmental stresses and harsh conditions, I'm going to turn that over to Ken.
Welcome, everyone. A little more definition on environmental stresses that can affect your application and the sensors you use within them. Of course, temperature and cycling, both thermal and loading type. We can see extreme, peaks in those temperatures and loadings as our products are being used. And then, one of the big challenges is to fight moisture and humidity. If, of course, if the product is not properly sealed, you can get moisture inside the load cell, inside the transducer. It can cause you lots of challenges, which again can happen when it's submersed as well. So it's everything about how the product is sealed and protected from outside issues in both the moisture, humidity, and the submersed applications. Vibration and shock, of course, that's more in the construction, let's say, of the load cell. There's certain things that you can do, that interface does, to help load cells, transducers survive heavy shocks and heavy vibration. Pressure, as Elliot mentioned before, that can be high pressure or even low pressure if it's a vacuum operation there, and flammable and explosive environments, which we'll talk a little bit more about. But of course, we all know the potential threats if those kind of situations aren't managed. Conditions categories, high temperatures. So a lot of sensors can be put into high temperature applications. They still need to get the measurements. Same thing with low temperatures. So, Interface has products that work in both types. Of course, that requires special kinds of compensation and possibly materials and strain gauges, which we'll talk a little bit more about. Frequent cycling of temperature. Sometimes environments can be pretty harsh and temperatures can swing wildly, and depending on how that environment affects the metal, in turn could change the measurement that's being used. Exposure to moisture, again, we mentioned that in the previous slide. It could be the enemy of your sensor in the application. Vibrations, shocks, and of course swings in temperature and pressure. All these things can affect your load cell performance and your application. I'm going to talk a little bit about standards and ratings now. So some of the big ones are intrinsically safe, and in general, intrinsically safe obviously is being able to operate within a hazardous location and not, let's say, trigger an explosion, some kind of event that happens. There's safety, of course. A lot of these transducers are used in lifting operations, and so you need to make sure that you're following all safety policy and that the sensor that you're using doesn't fail during that use. Regulatory compliance requirements, and of course those go specifically with different applications, so you just need to make sure that you're in compliance with those. And then IP ratings, which we're going to talk a little bit more about, which is ways to take a look at how different dust and moistures could be in your application, and then pick sensors or instruments that could be withstand those environmental challenges. ATEX and IECX certification. So those are international systems for certification of equipment that are used in explosive environments. So as you can imagine, those kind of areas need to be managed quite carefully. We advise our customers to make sure that they're always using certified installation technicians when they're working in those areas and following all the rules that go along with that. So there's intrinsic safe, EXI, and EXD, which is explosion proof versus intrinsically safe. EXI basically is for an apparatus that's installed in zones 1, 2, and 3, and we'll show a little diagram in the coming slide. But basically, the energy level of that device will be below any level that can ignite a gas or something to explode, as opposed to an EXD, which is in an enclosure that it can explode in. And we'll show another illustration as we move through. Suitable for use in zone 1, zone 2, and even zone 0 in some cases, which has to do with gas and actually the location of where the explosive environment is. And then, of course, these things are subject to strict inspections and manufacturing processes. We use all the right certified cable glands and connectors. And, as these products are built, there's many restrictions on the cable use and how they're, let's say, used with which type of sensor and what type of zone, etc. Next slide. So a little bit more detail on the intrinsically safe. So it's incapable of triggering a combustion or igniting any gases or vapors. So this is one type. So basically, by design, you're not going to be able to trigger an explosion in one of those hazardous environment situations. Explosion proof. Basically, you can see the star there's representing the explosion happening inside an enclosure, which will keep the area safe during the application. Next slide. And this is a really neat chart or graphic that shows you kind of where zone 0 would be, zone 1 would be, zone 2 would be. And, you would think that, well, maybe if I'm near gas, I know that's going to explode. That could be the most dangerous. But we've seen examples of where things have happened in zone 2, where it isn't as likely to have some kind of a explosion occur, and it does. So all safety needs to be practiced in any one of the zones. So, for instance, zone 0 is an explosive atmosphere that's continuous or for long periods of time. Zone 1, there could be an occasional explosion hazard. And then zone 2, it's not likely. But as stated before, we've seen situations where zone 2 has been a dangerous situation. So much care needs to be taken. Next slide. So this is a chart that talks about the IP ratings. So an IP rating is basically a way to select a load cell or a transducer and pick the right type or right one to go into a particular situation. The first number basically tells you what kind of solid foreign objects that this transducer could survive. And then the second one talks more about a number, or excuse me, water, sorry about that. So let's take a look at some examples on the next slide. So for example, if we have an IP65, can we go back one slide just quickly? Okay, so see where the number 6 is on the left side? It says dust tight. And then the 5 right next to it under the second number where it says protected against water jets. Now let's go to back to the slide we were on. So that chart kind of tells you, okay, if I've got an IP65 transducer, it's dust tight and protected against water jets. And then as you go through the different chart and the different numbers, you can see dust tight protected against powerful water jets, and dust tight protected against some water submersion and even continuous immersion in water. So you really have to look at your particular situation and make sure that you select the right transducer with the right IP rating so that your load cell or your transducer will perform throughout the application and its use. Next slide.
Thank you, Ken. So structural and material options, we'll talk about some mounting considerations and some material considerations here. So first of all, anytime we have any sensor installed in an application, we always recommend that that it's installed to the optimum condition. And we start talking about ruggedized type applications where perhaps there's going to be severe use of the load cell in the application. Becomes even more important to make sure that the application considerations and installation considerations are closely followed. So in this instance, we'll use one of our low profile load cells as an example of the best case installation considerations. So on the left hand side, you're going to see we have our load cell sandwiched between a mounting structure and a load. In this case, it's a compression only load cell with a spherically radiused loading surface on the top. And we have the load applied on it. You want to make sure that that load is applied directly into the load cell. There's no misalignment there. There's no bending moment being applied to the load cell. Making sure that there's a single flat surface and a single spherically radiused surface, so there's a single point of contact for the load to be applied, minimizing any off-axis load. That mounting structure should be stiff and not appreciably deflect under that load. And everything needs to be flat and aligned as best possible. The use case here would be, if you have an impact load or something that comes into this load cell load string, if everything is as aligned as well as possible and as stiff as possible, and you have an optimum installation, then it's going to be more resistant to overload damage than it would be if, let's say, for instance, that load was not as well aligned or there was a bending moment being applied at the same time as the impact load. So we want to make sure you consider those things. The application consideration on the right-hand side would be the same style of load cell, albeit with a rod end bearing installed and a clevis and a load. That rod end bearing would, for the most part, try to help that load be as axial as possible and minimize any bending loads that are applied to the load cell. Again, in the use case there is if there's a potential for an impact or a spike load that may exceed the capacity of the load cell, having these alignment considerations in place are further going to minimize any other combined loading condition, which would essentially function to reduce the safe overload capacity of the load cell, so minimizing that chance. Same goes with the stiffness of the mounting structure. If that mounting structure is actually deflecting under the load, then you could have a higher potential for misalignment, particularly if that impact load is at not an axial in nature, if there's a bending load or something else that's applied in combination there. Next slide, please. Multi-axis sensors, here's another example. These sensors all have very specific mounting considerations, and if they're not followed, you can have complications arise. So the 3-axis sensor is depicted in the center. You can see we have a combination of bolts and dowel pins that are used to install these. With multi-axis sensors in particular, where we have combined loading, we need to make sure that there are sufficient constraints on the load cell to keep the load cell from shifting under load. So some people ask us, hey, do we really need to use those dowel pins? The answer is typically going to be yes. For best results, use the dowel pins. And those are, again, we have a tolerance about the bolt holes. The dowel pins, much tighter tolerance. We want the sensor not to move under the loading condition of the application. The picture on the right, that could be one of our other 3AR series load cells. And again, these would have very specific mounting instructions and considerations as we're going through their dowel pins. Again, we want to avoid any slippage when that sensor is used. The same considerations would apply to any of our torque transducers as well. If it's a flange mount, you want to make sure that there's enough clamping force on that bolt circle to prevent slippage. Do not want to rely on the bolt itself for the actual reaction of the load. Next slide, please. Plates, if your load cells are mounted to plates, you need to make sure that they're flat, rigid. Parallelism is also key to avoiding any off-axis loading conditions. Using the proper bolt type and correct number of bolts. A lot of times we'll see applications come back to us with performance concerns, and it turns out perhaps that the mounting surface is not correct. The entire lower surface of the load cell is not supported perhaps, or the wrong bolt torque spec was used, and you're getting deflection or bending loads in areas that we don't want to see. Torquing the bolts to recommended levels, again, is important. The thread adapter engagement in the load cell and a preload applied to that jam nut, also critical. The example on the right is a series of multi-axis load cells with plates around them. It is absolutely paramount that those mounting plates are stiff enough and of a suitable material so that they are not deflecting under the load of the application. We want the sensor to be the spring, not any of the mounting equipment. Another example to speak very specifically to some of our load cells would be our low profile style load cells. So we have bases that you can mount the load cell to. They are heat treated to a specific hardness level. They have a specific flatness, and we have specific callouts for mounting screw grade, torque levels of said bolts, and flatness, again, that flatness specification. And obviously you want that entire load cell mounting portion to be supported. Next slide, please. Materials, these are selected dependent upon the application. So this is just an example of the different types of stainless steel material we might consider for a given application. So typically speaking, we're going to be using 17.4. That's our standard material. We do have other grades of stainless available depending on the actual application. So an example here would be we use a standard 17.4 for a lot of our load cells. H1150D would be one we would consider if it was a submerged application, if it was used for a marine or offshore application, or if there was a corrosive atmosphere consideration. So we've got pros and cons for different materials depending on the application. And again, these are all specifically selected for a given application. Next slide, please. Aluminum materials, same story here. Typically speaking, we're going to be using a T6, which is high strength and good for elevated temperatures. T4 would be good for good corrosion resistance. T81, aircraft grade, but perhaps not the most corrosion resistance. And T6, high strength and corrosion resistance, so a good combination of material properties there. And then as other applications require, other materials are considered. Another one that's important to consider is cable glands and connectors. So we can weld the load cell up. We can do all the other hermetic considerations on the load cell itself, but if we use the wrong connector, all those efforts go for naught. So we've got a lot of different cable options and connector options. Typically speaking, especially for rugged applications, a lot of times we're going to want to recommend using a connector on the load cell. Reason number one for this is if you damage the cable, that means you can just replace the cable if it's a connectorized load cell. If it's an integral cable on the load cell, unfortunately, it's got to come back to the factory for service, and a lot of times that can be an involved repair process with a hermetically sealed load cell. So types of connectors we typically would use: PG9 cable gland, a Lumbird connector, an LMG connector, a lot of subsea subcom connectors, or even a cable gland. If you do end up using an interval cable on a load cell, it's important to also consider what that cable end is exposed to. Again, if it's a submerged application, you want to make sure you have enough cable run to get it out of the media it's in, and recognize that there is a potential leak path dependent on the header type used on the load cell down that cable jacket. Next slide, please. Other material considerations that come into play dependent on the application. Again, we touched on cable. Some applications, it's going to be beneficial for the end user to use an armored cable or some sort of a cable shield if there's high likelihood of damage. And we also can optimize cable run lengths, cable conductor numbers, and other considerations such as that. Strain gauge is also, strain gauge selection, I should say, is also something we consider when we're looking at applications. That's primarily driven by temperature consideration and load cell type. That is, again, another variable that we consider. Next slide, please. Okay, I'm going to throw it back to Ken. Ruggedized test and measurement devices.
So we'll talk a little bit about some of the product that can stand up in out in the harsh environments. And first one here is our model 2400 series load cell. It's a I'll call it a standard performing device. It's made from stainless steel. It's got welded diaphragms, the connectors welded on as well. We have hermetically sealed so to keep any kind of moisture from ingressing inside the load cell. And you know, like I say, you can see this you know, in many types of applications out there, and you know, will withstand some good moisture. If it has to be outside, it'll do fine in that environment. Next slide. Here's a higher performing load cell, which is our model 3200 series. It's got performance up to plus or minus 0.03%. And so it's got a lot of the same features we saw on the model 2400 series, where it's got stainless steel construction, welded diaphragms. In this case, it's got a tight, watertight cable gland off the side as opposed to a connector. Of course, you can get that in various cable lengths as you need. And has a very high output signal, so you get more signal over the measurement that you get. Next slide. So this one looks similar, model 3400 series, except the difference is that it's an ATEX intrinsically safe design. So you get all the benefits of a high performing load cell like we saw in the model 3200 series. You get the welded diaphragm, welded connectors. You can also put this into an intrinsically safe environment. And it's got an internal amplifier, 4 to 20 milliamp loop powered. And then there's versions of this that can be used in unipolar application or bipolar applications. So, you know, it's good. We see this used a lot in our oil field customers, obviously for the ATEX protection. So, Elliot?
To touch more on the oil and gas segment here, we do have some specialized product designed for use downhole on well strings. This is our model IPCD pressure compensated downhole load cell. This has a very unique feature set in that it's electrically pressure compensated. This gets us around the need to have a hydraulically filled load cell, which requires service and has a relatively short service life. These are also very ruggedized transducers designed for high shock environments, very high accuracy. Again, no maintenance required. We do compensate these up to 20 KSI standard. And these do have a very broad range of temperature operation, compensated up to 350 with usage over 400 degrees. This is the standard version. We do offer many different variants of that with different ends, essentially, and different compensation features. The model WMC rod end load cell. This is another great load cell, environmentally sealed, stainless steel construction, very low deflection. Essentially, this is a welded stainless steel load cell that can be ordered in different submersible options and different feature sets. Next slide, please. This is a product that we've released in the last several years, one of our newer ones. Goes under the radar a little bit here. It's a 2000 high precision canister load cell. This is a hermetically sealed, what we call a ring type load cell design. Very high accuracy with extremely low hysteresis. So for applications that are fairly rugged, that do require high accuracy or high performance, I should say, this is the option that should be considered. This is available in capacities up to 1 million pounds, starting at 50,000 pounds. Very rugged. You'll notice that the connectors are actually recessed into the load cell body. This is so that you can actually roll the load cell if you need to, believe it or not, for transport around your facility. Also, if you've been a load cell user in a high channel count type environment, you know that it's not uncommon, unfortunately, for load cells to be knocked off during different rigging operations. So having the connectors recessed is definitely a feature. And it's also utilized as a glass to metal header behind the connector, so it is, again, hermetically sealed.
Okay, we're going to talk about weight checks and a couple of different mount products that we have. These are typically used in silo weighing. So you'll see a big silo with ledges set on top of these. So they'll weigh the amount of liquid or material that's inside of a silo. And so, you know, the features of this particular product is that we have either a zinc plated or stainless steel construction, depending on, you know, what your application requires. And it has a very high safe side load capability here. So if by chance you're in California or some area that might have seismic activity, this is the one you probably want to look at, because we don't want to see any kind of vessels tipping over. You know, it comes factory assembled. It has very good performance, and so pretty easy to install. Just a few bolts. As far as connecting to it, we'll say maybe lifting the silo isn't so easy, but the other parts are easy, that's for sure. Next slide. And this is a different kind of a mount that we have. This one is a fully stainless steel construction. It has a capability to go IP68. So sometimes customers have a washdown type application. Maybe it's a food industry. And so they have to wash down with a hot water solution to clean it. This will be an ideal type of solution for it. One of the key factors or key features of this one is that it has the self-load alignment feature, so it helps in the installation process. And then it has some safety features to prevent vessel movement. So again, once they're installed, they're very rugged, have good safe overloads, but you got to get them in place. And so this one has a lot of features that help you get it in place in the right way, in the right place. Next slide. So ruggedized load pins, you know, all load pins are, you know, fairly rugged, but with our designs, we have a key is that we do what's called a downhole gauge. So our gauges are placed inside the tube inside of the load pin itself. And so the gauges are inside, sealed, and away from the environment. You could get load pins in 3-to-1 or 5-to-1 safety factor. So, and then we make many custom versions. So in some particular applications, we've had, you know, even more than 5 times safety factor in, for instance, bridge applications, where, you know, these things could be seeing high seismic activity. So you can design them as long as they'll fit into the space you're trying to put them in. And then, of course, your performance will be affected as, if it goes thicker and thicker, it may affect your performance. But we go up to capacities of 3 million pounds, and obviously stainless steel material. And then we do have options for submersible and for ATEX in this particular product as well. This is our ruggedized product load shackle. So it's flame proof. So this is good for an intrinsic type application. You can see it comes sealed to IP67. So that's pretty high level of moisture protection, as well as the ability to be flame proof. So it's not going to cause an explosion to happen per se. A very rugged design using a Crosby shackle. And then you can see we can use some create some very rugged, let's say, cable exit options, so that what Elliot mentioned before, if there's a chance that somebody's going to knock a connector off or something, we can kind of protect it through a structural piece, as you can see on this particular pin. So obviously the pins themselves can be made of stainless steel material, and installation and use is pretty simple for this kind of a product.
All right, the Super SC. This is a new product that we've released in the last several months here. We've a relatively compact design for a relatively high force, is good to about 1,000 pounds, I believe. Generally speaking, it's IP66. IP68 versions are coming soon, with very economical load cell, high stiffness, low deflection, and when compared to a typical S-type load cell, it's going to be relatively less sensitive to an off-axis load or bending moment. Good product. Next slide, please. S-beam welded. So this is our WSSB welded stainless steel IP68 load cell. So very rugged stainless steel fully welded construction. IP68 sealed. We can also supply this with various accessories such as rod end bearings. So if you've got something where you're going to have exposure to hydraulic fluids or moisture or seawater, this would be a good option to consider. See, the S-type load cell. This is our model SSMH, hazardous environment, intrinsically safe S-type load cell. For those of you that have intrinsic safe requirements, this would be one option. This does have a conventional millivolt per volt output, so you can use your standard load cell instrumentation, just a bridge type output. This is good for tension and compression, environmentally sealed to IP65, also high temperated up to 290 degrees Fahrenheit. And again, certified for hazardous area locations when installed per the correct instructions. SSM and SSM2 sealed S-type load cell. This again is an S-type load cell. Available capacity is up to about 10,000 pounds and down to about 25. So we do have essentially it's a sealed gauged cavity. Typically these are sold with integral cables or a connector of some type, so environmentally sealed, up to about IP67, assuming that the cable end is protected. So another good option there. Very relatively cost effective as well.
This is a model WSS CLC, and this goes with our WSS CLC mount assembly that we saw earlier. So it's a IP68. You can see the accuracy down below, so it's a very accurate load cell. Fully welded construction and low height. So for those applications where you need a low height load cell that can withstand the environment, this would be a good one. It can withstand the washdown, as mentioned before, for the food industry. Next slide. It's our model LBM compression load button. Stainless steel construction. Strain gauges are internal, so is the compensation circuitry, nothing on the cable. So again, that's all protected within the load cell itself. It's got a small diameter. temperature compensated, and capacities from 25 pounds all the way up to 50K pounds. Slide. Next slide, please. There we go. So this next one is our model TSQ. So this is a big square drive reaction torque transducer. So people that have big drive devices that need to check the torque will use this type of a device. It goes up to 3 million inch-pounds of torque. It's got a male square on each end. You can see it's got quite an industrial connector on it with housing on it, high stiffness, and comes clockwise and counterclockwise calibrated. Then we got our 3-axis load cell here. And so, you know, they're just by design themselves, they're able to withstand full scale loading in all 3 axes, X, Y, and Z. So it's got low crosstalk. A number of them come in a stainless steel design. We also have some versions available for IP68. So we've had customers use these in a submersible application. They don't stay down for a long time, but if you follow the process we supply, you can use them, run your test, pull them out, dry them off, and continue to reuse them over and over again. So very rugged as far as the structure goes, and also can get submersion on this type of product as well.
All right, 6-axis transducers. Ken just touched on the 3-axis. The 6-axis takes the 3-axis and expands upon that a little bit with an FX, FY, FZ, and moments about each. For the measurements they take, it's relatively compact size, very low crosstalk, and these are temperature compensated. Broad range of capacities available. These work a little bit different than a standard bridge type sensor in that we don't have dedicated bridges for each axis. Rather, we're calculating outputs through a coefficient matrix and calculating the force and moment values. Number of features and benefits with that, in that we can actually tailor that coefficient matrix calculation around a customer's specific loading condition to optimize performance. And these are very rugged transducers capable of withstanding multiple axes loading up to full scale capacity without issue. Next slide, please. Model VSC2 rugged compact vehicle powered signal conditioner. So this is a signal conditioner that will take a 12-volt power supply. Very handy for applications where you only have 12-volt power available or lower voltage power conditions. Very high accuracy. You get plus or minus 3-volt output. Input gain sensitivities from 1.5 millivolts per volt to 4.5 millivolts per volt so that'll work for pretty much any load cell you'll get. 1000 hertz low pass filter, and again relatively compact for what you get there. So a good option for people doing vehicle testing. Next slide, please.
Okay, we're going to talk about sealed products and enclosures now. Here's a recap. Load cells, S-type cells, miniature load cells, coil tubing load cells, load washers, and load pins, all within this category. Next slide. Enclosures. So we offer a number of different enclosures for the instrumentation that we sell that complements the transducers that we just saw. Probably our number one type is a NEMA 4, and it can, and some of these enclosures, they're, you know, they mate to specific size indicators that we have. One in particular is an 1/8 DIN size enclosure, so they mount in and they can help provide environmental protection in your application. And then, so in this one scenario, the indicator front panel, let's say, will stick outside of the box. And then on another scenario, we can have the indicator and buttons for the instrument inside of a box, which provides even more moisture protection. And so that's what the difference between an internal mount enclosure and, let's say, a regular mount enclosure. We'll show you some pictures of it on the coming slides. Next slide. So on the left side, you're seeing an internal mount enclosure. So basically, you've got a NEMA 4 enclosure. And, of course, to access your buttons, you're going to have to remove that cover and then punch them in. But once you've got your indicator set up, you're viewing it through that clear glass window, and the whole instrument is protected by the NEMA 4. On the right side, you can see that we've got our instrumentation, so the right pair. You basically see you've got the instrumentation, whether it's a single or dual, but the instrument front panel display and push buttons are outside of the enclosure. So it just really depends on what kind of environment that you're going to be operating in, on which one may be the optimal, or whether you need to have interaction with those buttons or not. Which enclosure would be the optimum. Next slide. This is the overall chart like we saw for the IP ratings for NEMA ratings and NEMA enclosures. Most of our enclosure types that we supply are in the NEMA 4 or type 4 row. As you can see, going across, it's got, it's protection from incidental contact, falling dirt, circulating dust, settling airborne dust, light splash, hose down splash. So pretty good coverage. We do have one that is NEMA type 1, and that's our JB 1100 junction box. You'll see a picture of it soon. Next.
All right, extreme temperatures and cycling. One of the more common extreme environments we see are related to temperature concerns. So there's a couple different specifications to consider when you're looking at temperature effect on the load cell itself beyond just survivability. So this would be the performance related aspects of the load cell. So the rating of a strain gauge load cell is primarily dependent upon the materials selected for its construction. The actual spring element is typically going to be good for a very wide temperature range. Typically speaking, we're worried about the strain gauge backing material, cabling, and other materials in the actual load cell itself. Most of our load cells are rated for about 200 degrees. Typically speaking, the cable is going to be the limiting factor for most of them. And we do manufacture special models up to as high as 500 degrees Fahrenheit. With any set of materials, performance at extreme temperatures is going to be compromised to some degree. So a lot of considerations, and a lot of times most of the time it boils down to the specific application in terms of what performance impact considerations need to be made. Next slide, please. So parameters in relation to performance of the load cell across the temperature. So one of the primary effects is going to be temperature effect on zero, and that's the change in zero balance or the output from the load cell under zero load across the temperature change. Normally we spec this out as a percentage of allowable change per degree Fahrenheit. So that means the difference in output between a stable temperature and another stable temperature. So let's say you have a lab environment at 70 degrees Fahrenheit. The load cell is at a homogeneous temperature at that temperature, and you measure the zero balance and under that condition, and then you raise the temperature to, let's say, 85 degrees. Wait till the load cell stabilizes at a given temperature, and what is the zero balance at that temperature. The nice thing about a load cell is they do repeat very well at temperature. So once it's at 85 degrees, if you return it to that same temperature loading condition later on, it's going to repeat that same output level. And again, you can quantify the allowable change based on our specification. All of our load cells are 100% test, so we do not batch qualify. We specifically individually test and adjust each of our load cells that we ship. The other effect you're going to see is temperature effect on output. We correct for this through our strain gauges and matching them for the load cell material type. And this is the change in span or slope across a given temperature. And much like with the effect on zero, it's going to be a repeatable effect, assuming that there is no temperature gradient across the load cell, so a stable homogeneous temperature across the load cell. There is some effect on creep as well, and creep is defined as change in load cell signal over time under a constant load with no other variables. Temperature being a variable, it can affect that, and would also, as a result, affect zero return. So if you had your test started in one condition and ended in another thermal condition, you're not going to have the same zero return. Just want to also stress that load cells, again, will repeat very well over temperature, but they need to be at a consistent temperature across the load cell. If there's a gradient, you're going to see varied results. Products for extreme temperatures. Our intrinsically safe product, typically speaking, are going to be rated across the wider temperature range, rated for a specific temperature range, maybe a better way to phrase that. They would include our 3410 coil tubing load cells. 3410 family goes across the low profile family, the coil tubing family, and also our flame-proof bow type Crosby shackled load cells that we had up just a little bit earlier, and the model SSMH load cell, which is that intrinsically safe S-type load cell. We also have other products that we can optimize for high temperature use, just dependent on the application. So pretty much a lot of the load cells can be optimized. There's going to be some specific feature sets we have to build into them. And other options include special temperature compensation or noting down temperature performance. A use case example here. This is the image here is of a well service truck. This is the coil tubing truck. Coil tubing is a process used on wells where they actually inject this coil tubing downhole, and they need to maintain a consistent force exerted on the coil tubing while still not actually pressing too hard and damaging said tubing. So as you might imagine, well service, a very extreme environment, both from a forced application perspective and an environmental perspective. So they need to be able to tolerate perhaps not the most gentle usage and also the environmental extreme. So it's designed around those parameters. In addition to being intrinsically safe, you might imagine well service. They're going to have different gases emanating from the well, different fluids. So need to have that intrinsically safety requirement. Next slide, please. All right, Ken, exposure to moisture and submersibles.
Yes. Hang on a second. I'm waiting for the screen to catch up. There we go. So specs to consider, requirements related to water, surface and subsea. You've got safe and hazardous areas, extremes in temperature, capacity and loading requirements, functional and accuracy requirements, service and maintenance needs, quantity and instrumentation and output. Next slide. So these are really great questions to ask yourself when you're getting engaged in something like this, especially in the submersible area. You know, there's so many different things that have to be considered when you're doing a submersible product. And so, you know, standard things like what the cable length is, you know, is there a connector needed? Well, once you're in the, you know, subsea environment, you're going to need a special type of connector, right? You know, what are the temperatures this thing could see? What depth? So all these things need to be considered at the time that you're, you know, asking for a quote request or, you know, putting together your application, because that will change the nature of the design. Next slide. Here's some submersible products that we offer. We have different types of shackles. There are different shapes, a B type or D type. They're IP67 standard, but can be made obviously to go be submersed. We also do subsea, which means we're going really, really deep and really down underwater for a long time. We've done that. We have a history of successful installations in the field on that. All of our load pins are capable of submersibility. Our WSSB stainless steel S-beam that Elliot showed us. One of our lower capacity ones that works well in submersible is our WMC. So we'll see that in some kind of submersed medical testing. And then, of course, our WSS CLC load cell and mount, which we mentioned earlier, the IP68. So those are great products. Next.
All right, digging a little bit more into load pins here. As Ken mentioned, these are very handy devices and can be built with submersibility features. These are a great option if you're looking to replace an existing bolt or pin in a joint and you're trying to measure forces there. So these will measure tension and compression. So we've got a center loading structure, which would be like the whatever's applying the force. And then you have two outer reaction surfaces, and we have gauges placed internally. And the area that they're placed is what we call the shear groove area, which is a turn down section of the pin. So smaller radius to concentrate strain in that area. These are available in a lot of different options. We can do these with multiple bridges. We do something called an XY pin that lets you take a single primary axis, we'll call it the X-axis, and then an additional axis rotated 90 degrees radially about the pin. So we'll call that the Y-axis. That lets you essentially, if you have a rotating load or a load that is not perfectly centered on the pin, you can use the varying sensitivities of the bridges to calculate the total sum load. These are all typically going to be custom designs. It seems that no one joint is the same. So these are all essentially build to print. We can do a lot of different options here. We can do cabled, we can do wireless, we can do connectors. So a lot of different options there. The next slide will show some of the different configurations we can do. And a lot of different options, again, just to stress that. So cable exits, we can do radial exit, we can do an axial exit, we can do an end connector, we can do radio connectors. The connector exit a lot of times is going to be defined by access to the application and what room you have on one end of it. The one that we always try to recommend are the connectorized versions. Again, the integral cables can be nice, but if the cable gets severed, it creates some hassle for rework, and a lot of times it's a factory return. If it's a cable that's separate, then replace the cable and you're good to go. We've also, where possible, we try to recommend the recessed end connector is highlighted in the center there. That it may be a little more difficult to get the connector on the first time, but once it's on, it does have a lot more protection there. These also have a lot of different retention features. Typically speaking, the most standard version is to have a flat on one end of the pin. And then we ship these with a plate that would bolt to the structure and both axially retain the pin and prevent it from rotating in the application. There's a lot of other options we've done on the other side of the pin for, again, retention features, be it a split washer, be it a nut, or be it a cotter pin. So I guess the message here is there's a lot of different options, and we've done a lot of different applications. No one the same. If you have something that's rotating on top of the pin, like a bearing or a bushing, we can also fit these with grease ways for lubrication. So great option for, again, existing joints. There are some trade-offs versus conventional axial load cell and performance. But again, if you're trying to retrofit an existing mechanical apparatus, it can be a great option. These are some examples of the different submersible options that these are available with. Upper left is a subsea model load pin. You can see it's got a pretty elaborate cage around the cable exit that's designed to prevent floating debris or detritus from damaging the cable. So you have an armored jacket with a hose tube over it. The one in the center is another example of load pins with this one looks like the subsea connector. We have another option with the Crosby shackle type there. We've also got more conventional types of load cells that are submersible. So bottom left would be a female to female submersible load cell option. That'd be a fully welded stainless steel design with a submersible rated connector. The option in the center is what we call a tension link. So it's designed to have a shackle installed on each end and be pulled in tension. You can see this one also has cable protection installed on it. And then that image on the right is a completely custom sensor that's designed for submersibility for a torsion application. So the message there is there's a lot of different transducers that can be made submersible. And just depends on what the different application considerations are that would define how we put that package together.
So we're going to talk a little bit about instrumentation with enclosures. So these particular instruments come already enclosed in a either an EMA type or an IP67 enclosure. The first two, 920i and the 1280, those are multi-channel weight indicators that can also be used for batching purposes. So if you've got some kind of a cement plant or you're dispensing ingredients, those kind of things, food applications, you would use those. The 480 is very similar to that. It's just a straightforward weight indicator though, so you might be using this in an outdoor scale application or something like that. The 4 to 20 milliamp internal amplifier, we mentioned that before. It's for our ATEX products. So it's rugged, goes inside of our 3400 series products and can go in others and be intrinsically safe. We've got our BX8AS, which comes in an IP67 metal enclosure. We've had a number of people use that where they need a 8-channel data acquisition system, but it's going to be outside in a more rugged type test. We have our CSC inline amplifiers, which go from anything from 0 to 5 plus or minus 5 volt, 4 to 20 milliamp, and everything in between. And that's got an IP67 enclosure that we can put on it. We have our CSD amplifiers, which have different kinds of bus like CAN bus, and we've got ASCII, different kinds of digital signal conditioners that can go inside of this IP67 enclosure. So if you have digital or analog needs, we can do something like that in line. And then we've got our JB1100 junction box, which is kind of an intelligent signal conditioner junction box mix that comes in an EMA 1 enclosure. Next slide. This is a picture of a giant, large submersible load shackle used for a mooring application. And as you can see, it's got the cage on it that Elliot mentioned to protect the connectors from any kind of debris. Let's look at the next slide. And this next slide here shows it in use in a submersible floating wind turbine monitoring application. As you can see, the shackle is in between the anchor in the sea versus connecting to this floatable wind turbine. And so as the let's say the water moves up and down, they can measure the amount of tension that's on that cable. And then if by chance it breaks loose, they can also report that somebody needs to go out and reconnect it or service that piece of equipment.
All right, so some specific applications that use ruggedized products. This is a very common one that has its own specific requirements depending on where you're doing your testing. So this is an example of they're using one of our load shackles, which is very nice because it uses a standardized Crosby shackle, meaning you can use pretty much standardized lifting hardware on the other end. And it has a wireless broadcast unit back to a simple handheld indicator. So an operator inside of whatever's lifting it, be it a crane or hoist or something, can actually monitor it from wherever they are. Typically speaking, for customers that are doing lifting, a lot of times they require certified shackles that have been tested and proof loaded. Being able to use a standard Crosby shackle enables that, and having an instrumented pin allows them to monitor the loads as they're conducting their operations. Catenary mooring system. So mooring is pretty common. They don't want to let the ships float away in the night. So making sure that they're maintaining tension on the different anchor strings. So again, we have our Crosby shackles are popping up here again. So cabled load shackles paired back with our instrumentation that allows you to essentially, in this case, we're using a 9325 portable sensor with a USB interface, and then the customer's taking this back to their own software and monitoring over time. Again, if they're looking for stretch in the lines or failure of one of the mooring points, making sure they're maintaining the appropriate tension on those mooring lines.
This is a wave energy generator. So similar to the other application I spoke about, you've got the cable tethered to the bottom of the ocean, and it's what's in between this one now is an ITCA. That's a tension compression submersible load cell. We saw a picture of it in an earlier slide. The idea here is as the waves move up and down, the plunger goes up and down and it creates the generator to spin, and then it creates energy from that. And then they can store that into a battery or connect it to a grid so that it can be used for powering other devices. Next slide. This one here is a use of a load shackle. It's connected to a helicopter and a wireless system. And so what they're doing here is testing a cable line, making sure that it can handle the amount of payload it expected, and the cable can handle the load as well. Load is lifted with the shackle in between the helicopter and the load, wirelessly transmitted to a handheld wireless device or to a laptop computer, which resides onto the helicopter, inside the helicopter. Next one here is basically fatigue testing on prosthetics. So in this case, the load cell itself is a fatigue rated load cell. So it has to be very rugged because it's going to get cycle after cycle after cycle and test how rugged the prosthetic is in this case. Instrumentation here is our 9890, and it's connected to a PC computer to log and graph all the results of the testing. Next slide.
Right, bicycle testing. So any bicycle components manufactured have to be tested to make sure that they meet standards and aren't going to fail on a customer. So they're going to be simulating essentially test loads. In this case, they're cycling the shock aft and or forwards and backwards, making sure that as the mountain biker is hitting various obstacles on the trail, that fork is going to be strong enough. In this case, they're again using a fatigue rated load cell. Fatigue rating is essentially us saying that we're rating the load cell for many millions of cycles, as they're going to hopefully cycle that fork more than a couple hundred times to make sure it's going to be suitable. In this case, the customer has paired this load cell with our INF USB 3 USB signal conditioner, which is great for portable testing. Allows you essentially plug and play into any PC and log the applied forces and graph the applied forces over time. Seismic force monitoring. So a customer wanted to make sure that if there was a seismic event, the bridge was still structurally secure or still structurally sound would be a better way to put that, by essentially monitoring the forces that the bridge saw. So in this instance, we manufactured some very large custom load pens with wireless acquisition modules. Wireless is nice. You might imagine bridge is a pretty large structure, so long cable runs would not be ideal, nor would trying to maintain said long cable runs. So in this case, they used a wireless solution and are monitoring back to a computer system.
Okay, we're going to go through some do's and don'ts tips. Do know your exact specifications for any environmental exposure. Don't assume products can withstand the elements if they are not designed to do so. Do understand the maintenance and calibration needs for any measurement device that is installed into a harsh environment. Do evaluate all your certifications to ensure they meet your safety protocols, and don't use instrumentation in harsh conditions that are not made for that type of use. Now we're going to go over some frequently asked questions. So I will do the question asking and Elliot will do the question answering. So are all ruggedized products customized, Elliot?
That's a good question. It depends on the application. Typically speaking, load pins are all going to be custom. And dependent on the submersible application, most of those are going to be customized in some way for the specific application. Could be anything from a custom form factor to a custom venting option to an electrical output option to a specific temperature rating. Some of our ruggedized products that would not be customized or would be available off the shelf would be items such as our coil tubing load cells in most cases, our fatigue rated load cells, and other ruggedized stainless steel product.
What are the highest temperatures any product you make can withstand?
Good question. Really approaching 500 degrees is kind of the line for us, limiting factor being the strain gauge selection. When we start getting into that temperature range, it's important to note that there's going to be some performance degradation. So there are trade-offs going to that high. A lot of times we work with customers to try to minimize the thermal environment or thermal maximum temperature that the application sees. That can be done through active cooling of the load string or isolation of the load cell in the application from the temperature environment. Of course, we want to make sure, again, stressing that there's no thermal gradient across the load cell for best results.
Excellent. Are there different enclosures that can withstand water in a submerged setting?
Yes, there are. Depending on what we're trying to do, we recommend different options. Obviously, there's going to be different requirements based on depth of submersion and media. So we'd want to know the media type, the temperature, and depth of submersion and length of submersion to make the best recommendation possible.
What are the calibration requirements for submersibles?
So I'm going to go two ways with this. Number one is going to be if it's a standard product, it's going to be a standard calibration. Typically speaking, we recommend an annual calibration on most products. That is going to be subject to use type, however. So if it's an application where there's maybe less control of the force application of the sensor, it may be advisable to shorten that calibration interval. Whereas if it's a lab type environment with very controlled loading, then perhaps the customer can get away with extending that interval out because there's less possibility of damage in the sensor. Also is going to depend on the criticality of the measurement. If you're looking for a plus or minus 5% type measurement, maybe that annual calibration interval is not as reasonable as it would be if you're looking for a plus or minus 0.1% type measurement.
Good answer. What's the longest distance you can get a measurement or weighing data?
So if you're a cabled type application, then it's going to be essentially as long as you want to run the cable. Anytime we start talking about longer cable runs, we always recommend running 6-wire or what we call sense wiring, because given that this is a millivolt per volt output, so we're looking at outputs on the millivolt level, any voltage drop in excitation over cable run length is going to be or can be a dramatic error in the measurement. The other factor there is there's also going to be thermal effects on the cable run. So the longer the cable run, the more potential there could be for thermal effect on the cable that would impact that measurement. Running 6-wire cable, or what we call sense, essentially the instrumentation monitors the excitation voltage at the load cell bridge and compensates for any voltage drop across the cable. So that would always be recommended. If you want to go wireless and skip the cables altogether, we have technology that will get us to about between the 600 and 800 meter line of sight type of range. A lot of variables to consider there, including, I guess, the environment you're in. Is there a lot of Wi-Fi activity? how critical is packet loss across that, transmittal, and of course, other variables consider the application, including how synchronous the data needs to be.
So what's the difference between intrinsic safe and ATEX?
So there are North American certification versus ATEX certification. ATEX certification is primarily accepted in Europe. We do offer ATEX products and products that are North American certified. The question is, what do you need for your application? Does it need to be North American certified, or are you okay with an ATEX rating? We can accommodate either option through various means, but that is always an application specific conversation.
What's the smallest submersible load cell you offer?
We've actually manufactured some very low capacity gram level submersible load cells for a very specific application. For a lot of submersible applications, we go the route of trying to enclose the load cell as much as possible. So seal the load cell up as much as we can. For this particular application, we took the opposite approach and actually vented the load cell entirely. And then essentially the customer used it in a high dielectric mineral oil bath. And that essentially allowed us to submerge the load cell. Very good solution. Customer got excellent results with this. So it's probably one of the lower capacity ones we've done.
Are all load pins and load shackles engineered to order?
Good question. All load pins, well, 98% of the load pins I'd say we sell are probably going to be engineered to order. There are some very specific load pins that are designed to fit within standardized Crosby shackles. We've touched on it a couple times already, but those are pretty much standardized off of the Crosby dimensions. But anything that's designed to retrofit into a customer's joint, that is always going to be custom manufactured. Load shackles themselves are going to be much more standardized. And again, typically those force ranges are the form factors are going to be designed around the force ranges and dimensions of the standard Crosby shackles for those force ranges.
Do you offer accessories for ruggedized environments?
So we have a lot of different fixturing we do for customers. Let's say that they want to have us supply mating hardware as well. Maybe it's a large plate to support a duct or something. Maybe it's a special bolt. Maybe it's a specific thread size or special rod end bearing. So the answer there is always yes. It could be anything from a special armored cable to a very large custom mounting plate.
Are there other hazardous environment multi-axis rugged products available?
So in terms of hazardous environment products, we have done some custom work there, and it's actually we've taken a couple different approaches for customers over the years. Number one would be a individualized hazardous environment approval, where we're individually testing parts and then shipping with an approval label, to providing a simple, what we call a simple apparatus letter, where we state essentially how the load cell functions, and the customer uses that to certify suitability in the application or the environment.
Excellent, Elliot. Choosing interface. We are a trusted partner that offers complete ruggedized measurement solutions, starting with our engineers who design the products. They test and just people that build and test our products for use around the world. Interface is preferred for our precision. Interface continues to lead the industry in force measurement solutions due to our accuracy, quality, and depth of solutions. And then here's some reasons why you should choose Interface, all of them which are great reasons. Back to Jamie.
Thank you so much. That was really informative, and I really appreciate all the depth that you went into, Ellie and Ken. It provided a great context. We did have a question from Marcus about what an ATEX internal amp looks like. I'll probably have to send that over to you, Marcus, after the presentation, but we'll also try to include that in our wrap-up that we do online with this event. Oh, no, we went a little bit over, but as you can see, there's a lot to cover on this particular topic. Interface does have a big range of product offerings, and of course, consult with our application engineers, consult with our reps and distributors in the field. They'll work closely with you to ensure that you get the right thing. This event is recorded and will be placed on our YouTube channel. You can find us on our Interface Force YouTube line, as well as you can find all the updates on our website. We thank you for spending time with us today. If you have additional questions, be sure to reach out. We appreciate it. And our next event will be in 2023, and we hope to see you then. Take care, everyone.
Thanks.
Thank you.